So yeah, this question says, consider the geometric series, which looks like this, and then it says find f prime of 1. So I think in years past, students who I've had that have done this problem have found this one to be one that needs explanation. I think many of the other ones I've done as videos, they probably are okay on. Okay, so I have this infinite geometric series. So let's just write this out clearly, like try to piece together these concepts. This infinite geometric series, which I'll expand. Okay, so when n is a 0, I get a 1. When n is a 1, it's x minus 1. Okay, so this infinite series represents a function f of x. Okay, so we can say this. It equals f of x so long as our common ratio right, is less than 1. In other words, on the interval of convergence. So I hope it's clear that the common ratio is x minus 1. This question isn't really about the interval of convergence, so this isn't really relevant here for this question. But, like, what is f of x, right? Well, f of x is just going to equal, okay, again, it's an application of this general form. Okay, so this infinite series, or the polynomials, the partial sums, which are the polynomials, are going to behave like this function I'm about to write down. 1 over 1 minus the common ratio. Okay, so look, now we got our the function that's being referred to. If you distribute, you get 1 over 2 minus x. Okay, so look, this infinite series behaves on the interval of convergence, behaves like 1 over, okay, so f of x behaves like 1 over 2 minus x. So if we want to find f prime of 1, we just got to find f prime of x and plug in 1. Okay, don't forget the chain rule. So then, so that'll become negative 2 minus 1. Okay, so I think I get in the end I get a 1, right? These negatives become a positive 1, 1 to the negative 2 is 1, so I get a 1. So the final answer is that f prime of 1 is equal to 1. Okay, so we had to kind of do some piecing together of concepts, right? This infinite series represents a function, which we figured out using our a over 1 minus r form. Now I know what function it behaves like, and now I can take its derivative and plug in 1. You can also, actually, this is a great thing to note. I could also do this. It just occurred to me. You could also just look, so we could say this too. So this is alternative and this is totally fine. Our function is equal to this. Okay, and like you're allowed to perform calculus on power series. So just go term by term. So the derivative of 1 is 0. This derivative is 1. This derivative is 2x minus 1 to the 1. The next one would be 3x minus 1 squared. Just make that clear. Okay, so like I'm doing calculus. I don't even have to come up with the function itself like I did over here. What I'm doing right now is totally legitimate too. And so now f prime of 1 is just plug in 1 wherever there's an x. Notice you get a 1 and everything else becomes a 0 because of the expression x minus 1. So either way, you get a 1. In fact, this second way may be quicker than what I just did over here. They both work though, so whichever your brain did, whatever approach your brain did is fine.